All right, let's dive into state management in Flutter. Today, we're going to look at PipeX. And I'll tell you right now, this is not just another library. Nope, this is a tool with a really strong opinion. And that opinion is that good architecture shouldn't be an afterthought. It should be baked in from the very start.
Oh man, if you're a Flutter dev, you have definitely felt this, right? That moment when you change one tiny little thing and suddenly it kicks off this storm of updates. Widgets are rebuilding all over the place, your business logic is getting tangled up with your UI. That whole chaotic mess? Yeah, that's exactly what PipeX is here to fix.
So, here's the game plan. First, we're going to talk about that state management chaos that we all know and love. Then, we'll introduce the big idea behind PipeX, this really cool plumbing blueprint. From there, we'll see how it looks in the code, check out some pretty wild performance numbers, and finally, we'll talk about why its strict rules are actually its biggest feature.
Okay, let's get into it. You know, when your app state is just all over the place with no clear boundaries, it creates this totally unpredictable flow of data. And that leads to some very familiar and very frustrating headaches.
I mean, come on, we've all been there, right? Wrapping an entire page in one giant builder just to listen for one little value? Or watching your whole screen repaint just because you changed a single word? It's not just slow, it's a nightmare to debug, and it means your logic gets all tangled up in your UI.
So, what's PipeX's big idea? How does it solve all this? Well, it all starts with this awesome, super simple metaphor. Just think about your app state like it's a plumbing system. Seriously. All of a sudden, how the data flows just clicks. It makes perfect sense. Let's break down the parts.
First up, you've got the pipe. This is your most basic piece. It's just a single channel that holds one piece of reactive data. You know, like a counter, a username, whatever. And when that value changes, a little signal just flows right down that pipe.
Next, there's the hub. This is like your central junction box. It's where you bundle up all the pipes that belong together. So you could have a user hub that holds the pipes for a user's name, their age, their email. It's basically the command center for that whole feature's state. Okay, so you've got data flowing through pipes, but how does it actually show up in the UI? That's where the sink comes in. The sink is your faucet, your tap. You stick a sink widget exactly where you need that value to appear. It hooks up to a single pipe, and here's the magic part. When that pipe's value changes, only the sink rebuilds. That's it. Not the whole screen, not the widget above it, just that one little faucet. But you might be asking, what if one part of my UI needs to know about a few different pieces of data at the same time? Simple. That's what the well is for. Think of it like a reservoir or a basin that pulls water from a few different pipes. The well listens to a whole list of pipes, and it rebuilds whenever any one of them changes. This is perfect for something like a user profile header that needs to show, say, their name and their online status. And last but definitely not least, we've got the hub listener. Now this one is so important for clean architecture. The best way to think of it is like a pressure valve. It lets you react to a state change by doing something, a side effect, like popping up a dialog or navigating to a new page. But here's the kicker. It does it without rebuilding a single piece of UI. This is how you keep your actions totally separate from what the user sees.
Okay, so the whole plumbing thing is a great mental model, for sure. But what does it actually look like when you're writing Dart code? Let's jump from the blueprint to the actual build.
All right, check this out. A super simple counter hub. It's really just a class that extends hub. Inside, we create our count pipe and start it off at 0. Then we've got our increment and decrement methods that just change the pipe's value. But look closely. All the logic, the how things work, is tucked away right here. It's completely separate from the UI.
And then what about the UI? It's this easy. Seriously. You just wrap your text widget in a sink, point it at the hub.count pipe, and the builder gives you the value. Done. Now, no matter where you call increment from, the only thing that's going to rebuild is this one tiny text widget. Nothing else.
And that, right there, is the whole game. It's all about surgical precision. You're not just opening a fire hydrant and blasting your entire UI with state changes. No, you're installing these small, precise little faucets, your sinks and wells, only where you need the data to come out. And that guarantees your updates are minimal and, more importantly, totally predictable.
Okay, so clean architecture is awesome. We love it. But is it fast? Does this whole plumbing blueprint actually hold up when you put it under pressure? Well, let's take a look at the numbers.
So to really put this to the test, we're going to run something called Rainbench. The idea is simple. We simulate a crazy update storm by firing off 5,000 super fast state changes and just see how the UI handles it.
And the results? Whoa, they kind of speak for themselves, don't they? We put it head-to-head with Flutter's own ValueNotifier. PipeX finished the whole thing in just under 21 seconds. ValueNotifier? It took over 31 seconds. That's not a small difference. That's a massive gap.
So yeah, we are talking about roughly a 33% performance boost when things get really intense. And this proves it, right? This isn't just about making your code look pretty. This architectural model has a real, measurable impact on how your app feels and performs. Okay, a 33% jump is awesome, but the real question, the interesting part, is why? What's going on under the hood? Because it's not some magic optimization trick. The speed actually comes from what PipeX prevents you from doing. And this right here is the secret sauce. PipeX has one simple, super powerful rule. You cannot, under any circumstances, nest a reactive widget like a sink inside another sink. The code you see on the left, that'll just throw an error. It won't even run. And what does that do? It forces you to write code like you see on the right, breaking your UI down into smaller, self-contained components. And that, my friends, is the absolute bedrock of a high-performance app. And if you want to get a little nerdy for a second, here's the deep-down technical reason it works so well. PipeX isn't just looking at your widget tree, it's operating on the element tree, which is a level deeper. It's what Flutter is actually using to manage the UI. By stopping you from nesting these reactive widgets, it makes sure they never share the same part of that element tree, and that gives you a rock-solid guarantee that your updates will always be perfectly isolated.
So this all brings us back to the core idea, the whole philosophy behind PipeX. All these strict rules, they're not limitations. They're actually the main feature. This library is designed on purpose to enforce discipline.
Because when you play by its rules, look at what you get in return. You get guaranteed rebuild isolation, you get super clear boundaries for your state, you're automatically protected from all those common performance traps we fall into. Basically, PipeX makes the right way the only way. It turns good architecture from something you try to do into something that just happens.
And that leaves us with the big question, the one you have to ask for your own projects. Do you see this as a set of awesome guardrails that'll keep your app clean and performant for years to come? Or is it maybe a little too restrictive when you're under pressure and just need to get something out the door fast? That trade-off between having that strict discipline and moving at lightning speed, well, that's something every single one of us has to figure out.